This is the whiteboard explanation for experiment 2, elements and compounds, and also we're going to talk about chemical changes. So hopefully you've read through the background. I included the procedure in the background, and I'll be doing that throughout the term in order to just give you some reference to when you answer questions about actually after you have actually done the lab or witnessed the lab being done. And again, there's some videos that you can watch and parts of this. After I go through the background, I'm going to go through each activity and what it is I want you to do. So there's a table in the background that talks about what elements and compounds are, or matter in general. So matter is traditionally broken up into two subclasses. There are mixtures and pure substances. And by the way, the lecture covers this as well. All right, so a mixture is when you have one or more things, more than one substance in the same container. Each one keeps its own properties though. So for example, if I have a mixture of salt and sand, the salt acts like salt, the sand acts like sand, or sand and water, right? The sand acts like sand, the water acts like water. Because of that, mixtures can be separated by taking advantage of the differences in those properties. And we'll talk about that later when we deal more with mixtures. Mixtures come in two flavors, heterogeneous and homogeneous, and perhaps you're familiar with the prefixes. Hetero as a prefix means different. Homo is a prefix that means the same. So a heterogeneous mixture is not evenly mixed. So you can tell by looking at it that it's a mixture. So for example, water and sand, right? You can tell that there's two things in there, or even something as simple as oil and vinegar dressing. A homogeneous mixture is evenly mixed, or a textbook might say the properties are evenly distributed. So for example, tap water has a lot of things dissolved in it, or if you even had Kool-Aid, right? It looks the same all the way through. Okay, this lab isn't really focusing on this stuff though. We're going to focus on pure substances. Pure substances are one thing. So a pure substance is one thing, and that means it has one set of properties. However, pure substances can be broken down into two subclasses. There are compounds and elements. So a compound is one thing, pure substance, but it's made from simpler substances. So a compound can be broken down to simpler substances, but because it has one set of properties, it's a little tricky. Basically, you're forming new substances, and so that means you're breaking and forming chemical bonds. Compounds are represented by formulas, and we'll talk about that in a moment. Elements are the simplest substances. They cannot be broken down to simpler substances, and they are represented by symbols. This is where you always want to have a periodic table available. You should print one out, put one up on the wall in your home, because all the cool kids have periodic tables. So I'm going to clear this and just talk a little bit about that. All right, so if we go back to elements, you can look up elements on the periodic table, and they have symbols. And those symbols have one capital letter. So you can tell if you read a formula how many elements are in there by just counting the capital letters. If there's more than one letter, the others are lowercase. And you can always get them on the periodic table. And I'm not going to go through one right now, but I'll put that in the useful information. But for example, iron is Fe. Sodium is Na. All right? So, and the punctuation is important because, for example, cobalt is big C, whoops, that's a mess, big C, little o. Okay? Some of them make sense, but some of them, they're from other languages like Latin. Okay, compounds again, they're a pure substance. It's one thing made from other things, and they have formulas. And in the formula, for example, you have H2O for water. The subscript goes with whatever immediately precedes it. We don't write a 1, so if there's a 1, we just don't write it. So this means that there's 2 hydrogens and 1 oxygen. I'm going to write out oxygen because otherwise it looks like a 0. All right, if I had C, big O, that's carbon monoxide. That's 1 carbon and 1 oxygen. Sometimes we have parentheses like Ca3PO4 and then 2. The parentheses, the numbers would distribute it through. So this has calcium and there's 3, phosphorus, there's 2, oxygen, 2 times 4 is 8. Now why don't we just write P2O8? There's a reason for that that we'll get to later on in the course. Right? But these are all pure substances. Now, the other thing we're going to go through, I'm just going to go through procedurally what you're going to do, but I just want to talk about one more thing, and that is changes that matter undergoes. And actually, we'll talk about properties too. And then we'll get to the experiment itself. Okay, properties, there are physical and there are chemical. A physical property is, you can figure it out without changing the identity. So it's a change without a change. So I'm sorry, you can, yeah, so I'm sorry, it's not a change, it's a property that you can tell without changing the identity. So for example, the color, the melting point, so MP is the melting point, the boiling point, what temperature does it boil at. Chemical properties are behavior with other substances. So what does it do if you mix it with oxygen? All right, if it does nothing, that's still a chemical property. All right, flammability would be a chemical property. Now changes have the same definitions. There's the same classifications, excuse me. And excuse my handwriting, you've probably gotten used to it already after 1 or 2 of these. A physical change is a change very similar to a physical property without changing identity. So example, melting, any phase change. Tearing a piece of paper. In a chemical change, you make new stuff. And we're going to look at some chemical changes in the lab. I made videos of them. All right, so that's the basic background for this lab. Okay, remember you can hit pause, so if I'm erasing this quickly, remember you can hit pause. So now I'm going to go through procedurally what you're going to do. There are videos starting with activity 5, which is about chemical changes. So, but just to fill out the sheets, all right, so activity 1, you're just going to fill out the table. And you can look up on the internet. It's for, this is for elements, and you can look up. Same with activity 2, and these are for elements. So activity 1 and 2, and these are for elements, same thing. And then activity 3 and 4 also. You're just going to fill out the table, look them up on the internet. 1 and 2 are for elements, these 3 and 4 are for compounds. So you can look up, for example, you can look up the element and what's its name, where is it found in nature, things like that. Right? For chemical properties or physical properties, just give me 1. Now, let me go through the other activities. These ones there are videos for, but I'm going to give you a little bit of background that'll help you with these. All right, so activity 5, and like I said, I made kind of cheesy videos. These are chemical changes, and all I did is I did them so you can see what they look like. So activity 5, the one thing I'm going to give you is that you're asked to write down observations, and then you have to write a balanced chemical equation. So you're told it's magnesium plus oxygen, right? I'm burning magnesium in that video. Makes magnesium oxide. So we haven't done naming. So I'm going to give you this. I'm going to give you the formulas, and you can balance them on your own. So make sure you write these as balanced when you fill in the data sheet. Okay, activity 6, that was where I took a piece of metal and I put it in acid. All right, and what I did there is I took magnesium, and then I did the splint test. I'm going to write it this way, so I have space. All right, and this is all in the background, but the part with the formulas is not. That's why I'm doing this. Okay, so there's the unbalanced equation, and then the test for hydrogen is you take that burning splint, and so I took hydrogen, and if it pops, that means that there's hydrogen present. And that makes water. So you have this part. The formulas are H2 plus O2 makes H2O. Okay, so that's 5 and 6. All right. So again, you're asked to balance these equations. So you can hit pause to make sure you get this copied down. I'm going to erase it. And then activities 7 and 8. I'm going to call it ACT for abbreviation. Activity 7, I did potassium. And that makes potassium hydroxide. Plus hydrogen. You saw that one catch fire. That's a hydrogen ignites. And so this is K, it's an element. Water. Potassium hydroxide is KOH, and hydrogen is H2. And then activity 8. Okay, activity 8 was the acid-base reaction, and you saw it produce carbon dioxide, and the splint test for that, was that the splint went out. Didn't leave myself enough room. So this is going to be sodium acetate plus water plus carbon dioxide. All right, and so in formulas, this is, sodium carbonate, my bad. No, I was right, never mind. So this is NaHCO3, that's a C, plus acetic acid is 8, this is the acid in vinegar. You get sodium acetate, NaC2H3O2, water is H2O, and carbon dioxide is CO2. For activity 9, you're not asked to write any reactions, so I'm not going to give you really any more information. You're just supposed to say, fill out the observations. So this is enough background that you can go through the videos and you should be able to fill out all of the data sheets. All right, have a good time.